Very good evening, everyone. Can you guys hear me? Let me know in the chat. Thank you, Ansel. Very good evening, Ashwin. How you guys are doing? So we have like whole Saturday and Sunday. I hope you guys have practiced a lot of linked list problems. Most interesting one we have already done in our class. Very good evening, Joseph. So most interesting one we have already done in our class, like the reverse one or rotate one, or some of the approaches which we remember, like slow and faster approach, right? And I remember the last question where we were looking into the odd and even indices. There also we get to know about odd is equal to even dot next and even is equal to odd dot next. That question was also interesting. So did you guys practice all those problems? The palindrome one and the odd and even indices. Those problems you guys have practiced. Anyone practiced? Solve some question recursively. Okay. So palindrome one, odd even one. Everyone has resolved it. Do you guys are facing any problem with that? Those problems? Great, Ekta. What about others? Ashwin, Joseph, Sarad, Navneet, Anand, Parag, Subhajit, Divikanta. What about you guys? Did you guys practice those problem? Faced any problem? Waiting for your response, guys. So Anand is saying he has done problems. Nice, very nice. Ashwin is saying he has solved few linked list problem in college time. Must revise them again now. Yes, definitely. Those linked list problem are not very tough. If you can visualize the things properly, then I think the problem solving is very easy, because whatever we are visualizing, and visualization is also very easy in case of linked list. And we can just, whatever we are visualizing, we have to just write in the same way as we are talking while visualization. The same way we have to write our code as well. And that's what we have seen in, I think in our last 3 classes, we are talking about linked list. 3 or 2, yeah, 2 or 3 classes, I believe. And we are fully seeing that thing. Yeah, Likit, what is the doubt? We can start with Likit doubt. Only done the remaining recording because of office. Someone has given me assignment to develop books API in odd length scenario. I was developing it. Oh, okay, understood. Okay, so in odd length scenario, let's see. Let's see, guys. With the odd length scenario, what will happen in the palindrome situation? Okay. So in the odd length, so our palindrome string would look like something like this, right? Like let's take 5 length string. So it would be like ABC and BA, right? That would be the 5 string, 5 letters palindrome, right, guys? So if we see this in this solution with approach one, what was the approach one, guys? Can anyone tell me? What was the approach one for palindrome? Oh, you understood. Oh, you got it. Okay, no problem. Let's quickly discuss it, then we will just move on. I won't take much more time. So using arrays, or the better word would be using stack. That's what we are going to talk about today also. So that's right. So in first way, we will push all these elements in one array, A, B, C, B, A, right? In one array. We can say this array as a stack. It's just a name. Right now, this array, this is just the array name. Okay. And then we can just start a loop on our string, iterate over our state, iterate over provided string. While iterating, pop one element from the stack array. So pop one element from array and compare it with the provided string. Correct, guys? That was our first approach. So we have seen this approach, and we were saying that this approach will take extra space because we are taking array. Time complexity is same, O of n, because we are just iterating whole array. So time complexity is not going to change anywhere. For the space, we were saying this is using some extra space. Is there any way we can reduce this space to 1? So that's what we have gone through the approach 2 also. And I remember in that approach, what we did, we have gone to the middle element and then we have reversed it from there, right? So ABC, and then when we will reverse it, it will look like this, something like that, like A, B, and C, right, guys? While we have to reverse the second part of this, C will still be there, and ABC we will also get the reverse part of CBA. So first, the second part of string is CBA, and when we will reverse it, we will get the ABC. And after reversing the second part, we have to just simply compare the values. After reversing the second part, compare both linked list values, and if they are equal, we'll just say that the string is palindrome. Okay, guys. So that was about the palindrome, and according to slide, so I think they have provided the new slides now, and now in each slide we will be having the previous class assignment discussion, right? So we have already in our previous class we have already discussed the assignment question also. So not much here to discuss about this, but yeah, still if you guys have any doubts on this one, I could spend some time on that one, on the both of the problems here, which is the palindrome, which we already discussed, and second one is the odd and even indices. And the odd and even indices, this was, yes, these are already done in last class. That's right. So odd and even indices, if you remember the logic, there was even dot, the main thing to remember while solving that problem was even dot next is equal to odd dot next is equal to even. That was the main thing which we need to remember while solving the odd and even indices problem. Once you remember that logic, after that, it just checking for while condition, where we have to stop, where we should not have to, where we should not stop. Those are the small things are there. It was very similar to reorder linked list. Yes, we have done one question, rotate linked list and reordering linked list. So yes, we can say that it was at the last step in the, if you guys remember about the rotate linked list or reorder linked list. So what was the process which we have followed there? First we have find out the middle element, then we done the reverse of second part, and after that we were just merging those linked list, right? A similar thing, little bit less, like you have to the odd and even indices little bit easier than that, because in this one We just need to traverse our pointers here and there. And after that, once we are at the right pointers, like odd indices or the even indices, we just need to make the proper connection. And then at the end, we have to know where to stop. But the important part for odd and even indices, which everyone has to remember, like whenever they are seeing this question, that even dot next is equal to odd, or odd dot next is equal to even. That was very nice thing. Okay. Do not reverse the second half. Yes, in this one we don't reverse the second half. Okay. What about that one? Anyone read about that question? The start element of cycle. Likhit, have you read about that? The start element of. See, guys, on that problem, actually, we were missing one thing, and that one was like, let me show you one more time very quickly. I think if you do not have any questions on the assignment part, we can talk about that much. That one, I just followed that Geeks for Geeks explanation to understand that one. And you know, what we were missing from our equation, that was the number of cycles. That was the number of. Sir, I just joined. Did I miss something? No, Raj, we are just discussing our previous class topics. First one, the palindrome one, and the second one, the odd even indices, which we have solved in the last time. And if you have any queries on those things, you can ask it, Arad. And if we don't have any queries, we can discuss little bit about the problem. You remember we were seeing little bit like the not problem in coding, in just the in understanding, just in understanding that about the start element of cycle. Just little bit we were having some doubts. So I have already provided the Geeks for Geeks links to you guys. But so see what we were missing there, guys, while we were creating the equation x plus y, right, for the slow, and then we did x plus 2y plus z for the faster one, right? You guys remember? Because the faster one was running little bit faster, little bit like not little bit, two times faster than the slower one. So that the two is there, right? That is not the, that is only that the number two which we have taken, that is only going to true for that scenario. That is only going to true for that scenario when we have when we have five elements and seven was meeting. But in the real equation, they have taken that as a n, because the faster element can take n number of cycles, right? Faster element can take n number of cycles hitting the before classing with slower one, correct? And after that, so the equation will become then x plus ny, x plus ny plus z. Yeah, sure, let's draw it, let's understand it. So before that, anyone has any doubts on palindrome one and odd and even indices? We can first see those problems because those are our assignment questions. If not, then we can spend some time on this one. And you know, I solved that one, the same one, right? In my in my notes, I solved that one. In that one, we were stopping at we were starting our cycle from 7, right? In the last question of cycle start, I remember we have started our cycle from 7, right? No, not for 4-1. 4-1 we have already understood. I was talking about the 7, the last one, where our cycle was very small. I think we have started from 7, 8. Okay, yeah, 7 or 8 somewhere. Yeah, it was near to that, 8 to 7, yeah. So I followed the equation there, and it has given me. If you guys have also practiced in your time, so I have given the time for the F cycle. It has taken 2 cycles. So our equation has become at the end x minus y is equal to x minus y is equal to z. Let me show you that one only. So our equation has changed there. Let's you guys are able to see my screen, right? Yeah, let's quickly see that. So guys, so let's see. This is the starting point where we have taken 1, And this is our cycle, like 1, 2, 3, 4. I'm just taking the first the smaller like equation, 5 or 6 we can take, huh? Here we can take 7, here we can take 8, here we can take 9, here we can take 10. Okay, and let's start the faster and smaller one. Faster is going to be blue one, and red one is going to be a smaller one. And we are starting from the same point right now. But you guys remember, right? We start from faster, we start from here, and the smaller we start from here. But we are right now starting from same place. Okay, so let's see. The smaller will come first here. So first smaller will come here. Then faster will be at the first position here. Let's see where they are classing. Right now, the smaller will be here. Smaller will be here, and faster would be at the faster was here. So yeah, faster will be here at the fifth, right? And now smaller will be at the at here. Now the faster would be at the seventh place. So I can see first cycle is starting for faster one. First cycle is starting. It's starting. Okay. So faster is a seventh place. Now slower would be here, right? Slower would be at this place 5. Now we'll move faster to 9. Correct. Faster is here. Now slower will be at 6, right here. Now our faster would be at 10 6. Faster will also be at 6. Now we'll move our slower to further here, right? You can see faster has completed one cycle, completed. Now let's move further. We have already moved our slower one. Now move our faster to 8. Faster is here. Now move our slower one again, 7 to 8. Okay, slower is here. Like, are we going like wrong somewhere, or we are going correct in the way? We are at the right place, right? Correct. We are at this place, right? Yeah, yeah. Now here they have met, right? Because faster also and slower also moved to same place. So now this is the place where they have clashed, and faster has completed one cycle here, right? So now after that, what we did in this equation, so this was our x, and then from a starting point and where they class, we have taken that distance as a y. Okay, and then this distance we want to find it out. Correct? And we are saying that this is the classing point from here to the starting point which we need to go. So what we were missing here from the last time earlier, what we did, see, if you want to just calculate for this scenario only, for this scenario, so it would be like this: lower is equal to x plus y, right? He has just moved x plus y. And if we talk about the faster one, the distance which he has covered, so x plus how many cycles he has taken, like he has completed this whole one, right? We can consider the circle length, the length of this circle as well. That would be c. That would be c, right? But in this scenario, we can say, if we want to just like give more variables here, so we can say this would be our z. Correct. This distance would be z here. So if we talk about this one, so let's see. So and circle length would be y plus z. Correct, guys? The circle length would be y plus z. This is the y, and this part is z. So circle length is y plus z. So let's talk about the y, the faster one. How much he has completed? So he has completed one time y plus z, and he has completed only y and one extra y, right? So y plus z he has completed one, and then he has y extra here. Correct, guys? So in this equation, x plus 2y plus z, and there we will get x plus. This will come back to the same scenario which we have done earlier. So it would be two, like because slower one is running, the slower will cover half distance. So it would be 2x plus y is equal to x plus 2y plus z, right, guys? The same time, in the same time, the distance would be. Then we did 2x plus 2y, x plus 2y plus z. And in this scenario, we got x is equal to z. But this will not be true in all conditions. That's what I want to tell you. This is not going to true in all conditions. In some scenario, there might be possible that he has run more cycles here. So that's why in the examples, they have taken this as a n here. The number of cycles, they have taken it as a n. Understood, guys? In the number of so till now we have did correctly, right? Everything is correct. Everyone understood. We already done this in last class for this scenario, right? But see, this is just for this scenario. But for the general perspective, but for just the general scenario, so how will this look like? What they have done that for the x distance, this is x plus y, that is fine. But for the faster one, because faster one can take multiple cycles, faster one can take multiple cycles. So this could be for faster one x plus, if I take the number of cycles as a n and hold distance as a c, so x plus nc, this is number of cycles, and c is the circle length. So that's how they are calculating it. And then at the end, the equation which will be coming at, and then after that, I think there would be some more distance, right? Where they are meeting like this thing, which would be y. So y will also come here. This is the circle length. How many times he has done the circle part? How many times he has like rounded it out here? That you can see from here. The same equation, I'm writing it like this: x plus nc plus y. And now we can calculate it properly. And see, guys, for the slower one can also be there one cycle. We right now I'm not considering the slower one has any cycle or not, but the faster one, there would definitely be cycles, right? So that's why let's summarize this one. So x plus y would be x plus, we can say c as a y plus z plus y. So x plus y is equal to x plus nx plus nz plus y, right? Sorry, ny is there, correct? And these are some like n and z. We can ignore these things, or if you do not want to ignore, still we can see what are the values which we can write it here now. So we can see xx could be we can cancel it out, plus y is equal to ny plus nz plus y, right? So if we common it out, so ny n plus 1 could come for y, and then nz could come here. Then like we can solve the problems here in this scenario in this way. But what the important thing which I want to tell you here, this that we need this always, it depends on the second part, that this will always depend on this n1 and number of cycles, how much he has completed, right? We can solve it out the problem like the equations later. But the important part is, that's why actually that's why actually the values will be different, equation will be different every time. But at the end, this part, if you want to find out this value, this would be equal to this one. But yeah, equation will be different. Equation would be different. Like when I taken the 7 one, when I have taken the 7, let me show you the 7 one. In the similar scenario, if I have taken the 7 one, so I got their equation as a x is equal to y plus 2z, because y has taken two cycles there. So it was look like this: x plus something like that 2y plus 2z. In the same scenario, I think we have missed here also, right? When we were taking, oh yeah, that's fine. So in this scenario, it will be like this: x plus 2y plus 2z plus y. In the when our cycle was starting from 7, and for x it was for slower one it was x plus y only, and then for faster one the equation was like this. So if you will add it, x plus 3y plus 2z is equal to x plus y, and then yeah, 2x, sorry, 2x plus 2y. Here also we missed that 2x, sorry. That's why the confusion was here. Here 2x plus 2y. Now, if you want to calculate it here, so this x will go here, this 3y also will, this 3y will also go here. X minus y is equal to 2z. That's what I was saying. X is equal to y plus 2z. So this will equation will come in that scenario. Understood, Likit? So this equation will not work in that equation. Equation will be this: x is equal to y plus 2z. And see, what is the meaning of this? What is the meaning of this? Guys, it's not like that. If the faster is starting from here, if the faster is starting from here, or faster or slower, it does not mean he will reach here at the 6th point only in the 4th step. It could be possible, it could reach in the cycle also. See, in the last question where we were like stuck, so it was like this: 1, 2, 3, 4, 5, 6, 7, 8, and then our cycle start, right? It was 9 here, and then we have 10, and then we have this, right? This was the problem, right? In this scenario, like we were meeting at 9 point, right? We were meeting it here. Slower and faster was meeting here. So it does not mean, guys, that it will only take 2 steps to reach here. It does not mean it. That's what actually I explained it wrong. With this example, I only explained that x is equal to z. It does not mean like this distance will always be equal to this one, but this one and this the pointer which is starting from here and the pointer which is starting from here, that is definitely true. These are going to meet at this point. So this pointer could take multiple cycles also. Like the one is first starting from here, then it is starting from here, then the first one come here, then it comes here, then 3 is coming here, then again it moves to here. Like that, guys. That was actually not clear in last class. You know, it will move like this, and then they will definitely meet. Then they will definitely meet. That was only the reason where we were confused. We were not confused about the equation or anything. We were not confused about the equation or anything. We were confused about because what I was thinking that this value should be equal, and in every scenario. But that's not true. This x is equal to z is only happening on this scenario when somebody is meeting at 6 and the pointing is 8. But if we have something scenario like this one where we are starting from x, so it could be possible the pointer which is starting from here, it takes a lot of cycles, then they both meet, which is from here and from here, and that is, I think, y plus 2z. That is only y plus 2z. Understood, guys? So that actually the missing part was when somebody wherever they are classing slower and faster, from there to reach the starting point, it's not like that they will only take that much distance. They could again go back in the circles, and then they will reach to the, but that the main condition, the main thing is whoever is starting from starting point, from the starting of linked list and from the classing point, they will definitely meet at one place. That is true. That we can prove from the conditions. That we can prove from the condition. That is totally true. But in the last class I was explaining x is going to be equal to z. That's not true. That's not true. We have already seen that in our last class where x was not equal to z. And if you will try to solve any of the scenarios now with this understanding that the faster could take multiple cycles also to before meeting to the start point. So with that thought, so now it clears, right, where we stuck in our last class. So Hariharan saying, sir, why plus y is also coming? So plus y is coming if you're talking about this plus y. So Hariharan, we have completed one cycle here, and that one cycle is y plus z, and then he has taken extra y before classing with the slower one. That's why this extra y is coming. Okay then. Okay, so because after completing n circles, the fast and slower point meet at a point that is at a distance of y. That's totally true. That's a y from the start of cycle. That's totally true. So both the pointers can take multiple cycles to meet. So it's safe to take n variables on both sides, right? Yes. Totally right. That's why I told you in some scenarios this y could also be n y, and this n could be different. This would be n2 and this would be n1. In some scenarios I have seen x plus n1 is equal to y, and then there would be x plus n2 y plus z plus y. This is the actually true scenario will be looking like this. Let me write it down. X plus n1 y is equal to or and see this will not only be y. One more thing, this will not only be y, this could also be c, right? The same circle length plus y, and then here it could be n plus n2c plus y. This would be the real equation. Then it would be 2x plus n1c plus y is equal to x plus n2c plus y. And why n1 and n2 are different? Can anyone tell me why n1 and n2 are different? Anyone tell me in the chat why n1 and n2 are different? Yes, number of circles, correct. They both go for same rotation. Yeah, same rotation, but number of circles could be different because faster is like he can move little bit faster, so he could be more rotate. So that's why like n1 and n2 could be different, and then we can solve the scenario 2 n1c and yeah, 2 n1c plus 2y, x plus n2c plus y. And then we can just simply solve can come here. So x is equal to, and we can send these things there. So it would be n2c minus 2n1c plus minus y. So x plus y is equal to cv and n2 minus n1. Something equation will be looking like this. And I think this equation could be generic. This equation could work in all the scenarios. Understood, guys? But yeah, the important point was which I told in the last, that before meeting to the pointer, the faster one, and the which we are starting from the start one. So start I'm giving the name as start pointer. The start pointer and faster point. So when they both are meeting, it could be possible that a faster one can take multiple cycles. So that was only missing in the last class. Other than that, we were okay. We were good. So I hope, Likit, it has now cleared some of your questions, or for others also. So when I read that Geeks for Geeks explanation, then they told me the last line because I was only missing. I already understood the equation was different, but I was not able to get the point why they are saying x is equal to z. Then I get to know that from that explanation that that's not true. The faster one can take multiple circles, then he can meet to the start pointer. Okay, so that was guys from our last class or previous classes. Okay, let's start a new topic today, and that topic is going to be stack, guys. Okay, that topic is going to be stack, and I personally would say that stack and queue are like a very easy topic, and stack and queue are like they have a lot of similarities. Stack and queue, they have a lot of similarities, and you guys won't believe, in lot of scenarios, lot of like BFS, DFS, lot of graph problems and lot of tree problems. Those like I would not say lot of problems are people are solving. Whenever they are solving, they are using stack and queue. Lot of places. It's not one or two places. Lot of places. Lot of problems they are solving with stack and queue. Okay, guys. So in today's class or in next class, we are going to discuss fully on the stack. Then we will jump into the Q1. Okay, on the Q, not Q1 quarter, not the Q, on the Q. So first, let's understand what is a stack. Okay, so I hope when everyone has gone to marriages, right? If somebody whenever we have marriage in our family or in and friends marriage, everyone has gone right there. So you guys have observed one thing. They in all the marriages they keep one common place where you can go and pick plates for taking foods, right? So have you observed the pattern they follow for keeping the plates? Right? How they keep it? They keep all the plates at one by one, like one plate, then on top of that, on top of that, top of that. Yeah, one after another. So you will be seeing plates like that. And how you choose the plate? Whenever you go to marriages, how you choose the place? Is there anyone? Is there anyone who is very smart or clever who take the plates from the middle or from the last? Right? Hence anyone. Deepak is there. He's smart, so he takes plates from the middle. But Nilanjan is also in the same. But the general pattern or the that's also true. So what I generally do, I just keep the one plate. First, I take the first place, keep it away, take the second plate. I do not go to second, like I do not pick all the plates and then go to the middle one. Okay, so yeah, so that's all the fun part. But yeah, see why they are doing it. So when they are doing it, what they want you to do that. The normal procedure is the normal pattern is you have to go and choose the plate from the which the plate which is on the top. Then you can take the second plate. Then you can take the third plate, right? Then you can take the four plates. That's what they want to say to you. Yeah, chairs examples is also right. Hariharan has given the chairs example also. So the in the chairs also you can see they keep all the chair one top of another, one top of another. And whenever you want to choose a chair, you have to first take the first one out, then the second one, then the third one, then the fourth one. You can see a lot of scenarios. So if you will see the these type of patterns in your real life examples, you will see lot of examples would be there for the stack. So see, guys, it's nothing. It's nothing. Stack. Whenever people say to you about a stack, they are just saying that you need to follow some pattern. You need to follow some pattern, and that pattern is you have to take elements always from the top. You can insert whoever you are inserting first. So let's see in the chair example, the first chair, whoever have kept the first chair, that chair will only be used at the last. When all the chairs on top of it already been used, then only the last one will be used. Am I right, guys? Whatever chair, like the first chair who has been kept, and after that people are starting putting chairs on top of that, so the first chair will always be used at the last. Am I right, guys? And the last chair will be always used first. जो भी लास्ट चेयर है जिसको सबसे लास्ट में रखा गया है वो सबसे पहले यूज होगी. That's right. So that's what the stack is, guys. That's what the stack mantra is. That's what people say. The stack mantra is last in first out. Last in first out. तो जो भी लास्ट में चेयर आई है वो पहले आउट होगी. Last in first out. And sometimes people say first in last out. मतलब जो सबसे पहले आया है वो सबसे लास्ट में जाएगा. You can understand this mantra with a chair example. First in last out, last in first out. This is only stack, guys. This is only stack. There is nothing else in this stack. This is only stack. Last in first out, first in last out. That's why it is very easy. अब देखो what is the meaning of it? There are a lot of problems. You will see a lot of problems. Like if you remember the palindrome problem, I will show you very quickly the stack use of a stack. You can see in this problem, first we inserted these elements in a stack. So let's just see if I'm creating something like that. This is a stack. Okay. So first I inserted A. A is here. Okay. Then I inserted B. This is second chair. I'm just considering this as the alphabet or chair you can consider. This is C, then this is B, then this is A, then this is A. Now what stack says, जो भी first last आया है वो सबसे पहले जाएगा. So now if you want to take elements from outside of this stack, you have to always take from the first, take the element which has come at the last. So always you will take first A, then the remaining element will be here, the B, C, D, A. Now A is outside. A you have already taken out. Then B you will take, then B you will take, then C you will take, wherever you want to keep it, C, then you will take the D, then you will take the A. So आप समझ रहे हो? अगर हम इसको number wise करें, if we do it as do this as a number wise, so like if we have 5 chairs, chair 1, chair 2, chair 3, chair 4, chair 5. So सबसे पहले ये chair आई, हमने इसको रख दिया chair 1. Just visualize it as we do in the real time also. So chair 1 हमने kept कर दिया, ठीक है. अब हमने chair 2 लिया, वो उसके ऊपर आ गई, ठीक है. Chair 3 वो उसके ऊपर, chair 4 on top of that, then chair 5. Now all the chairs are at one place in one data structure. All the chairs are at one place on, and that's what we say the data structure, right? Where we keep all the data at one place and then we can properly organize them. So you can see they are properly organized, right? Now if you want to take something out from this chair from this stack, you will always have to take the first one, which is C5. First you will take the C5, then you will take the chair 4, then chair 3, then chair 2, chair 1. I hope you are already visualizing it with the real time chair scenario. Everyone understood now what is the meaning of a stack? I hope you have already visualized the same with the stack which we did with the real time example. Okay. So let's see, guys. In the programming world, when we are inserting something, when we are taking out that element, we have given some name to them. We have given some name to those functionalities. जब हम insert कर रहे हैं, हमने उसको कुछ नाम दिया है stack के लिए, specifically for stack. So whenever we are inserting something, we say that we are pushing it. You can see, whenever I'm inserting anything, whenever I'm inserting C1, I'm saying I'm pushing C1. I'm pushing it into into the stack. और जब हम निकाल रहे हैं, when we are keeping it out or deleting it, we are saying this is pop. Whenever we are taking out any elements, we are saying that operation is known as pop. These are the terms which stack uses. These are the terms which we use in stack. So what is the meaning of push? Push means we are inserting it. Pop is when we are deleting it. Okay, guys. So now in a stack, you can see you first 3 things you need to remember only. One is LIFO, FIFO. So LIFO, FILO. LIFO means last in, first out. LIFO. Let me show you also what I'm saying. LIFO. LIFO. It means last in, first out. तुम ऐसे visualize रखोगे. मैंने इसे दिखा दिया ना. Now it will be visualized. And second one is FILO. Both are similar. First in, last out. Okay, guys. Whenever you see these type of scenarios, you have to use stack. And after that, what are the next thing you need to remember? That is push and pop. Push, when we do push, when we want to insert something. When we do pop, it means we want to delete something. Understood, everyone? Push and pop from array functions. Yes, these are the functions which array also uses. Okay. So push and pop, these are the function not array uses, Nilanjan. These are the function push and pop which JavaScript array uses. Not all the array uses push and pop. If you will go to the C++ or Java, they have dot add in the array. They have dot add somewhere. Some other methods are there. This push and pop are the JavaScript array functions. Understood, Niranjan? You cannot generalize these methods as a array functions. These are the if somebody wants to generalize push and pop, that is only they can do for stack. Stack has provided push and pop as a generalized method. Whatever language you are using, whatever language you guys are using, you have to use for a stack push and pop. Wherever whatever language, C++ or you are using Java, .NET, Python, whatever your language you are using. If you want to use the stack features, you have to use the push and pop. And push and pop should work in the similar way. And you can see in the JavaScript array, push and pop work in the similar way. Push means insert karo something at the end. In our JavaScript array functions, push, whenever we do push, it always insert at the last index, right? And when we do the pop, it always delete the last element from the array. So push and pop does the same thing. Understood, Nilanjan? Are we good with that? Okay. Hariharan, is a stack a data type? Is stack a data structure? Stack is a data structure, like array, like linked list. Stack is also a data structure. Okay. Java will first slap us with good exception if we try doing it. Okay. So have you worked on AWS Lambda function? Yes, I work on the AWS Lambda functions also, Deepak. AWS Lambda functions are very similar to our Google Cloud functions and Azure functions. They all are similar. And luckily, they are using the Node.js there. Like other languages are also there, but I'm saying Node.js is also there everywhere. So Lekit is saying in Python, append is there for the array. You see, Nilanjan, answer to your question. When you are saying push and pop for array, it's not true. Push and pop only for JavaScript array. You can see that different examples people are giving here. Yes, and currently I'm also. Great, Deepak. Nice. Okay, so let's move further. Let's see. Let's see what other method. Oh, let's see. Let's start creating. Let's start creating. Working in Lambda functions, but I'm using TypeScript. Okay, very nice. TypeScript is the actually TypeScript is the next thing where most of the organizations are moving forward. We will talk about it later. Whenever you want, you can ask to Anshul. We can talk about TypeScript in a further classes. Okay, so let's move, guys. Let's create like as we created the linked list class. Let's create a class for stack also. Okay, and let's see in the slides if I miss anything. But that's all about the stack only, guys. The only three things you need to remember: Philo and LIFO. These are the strategy which is stack follows. Then there are two methods, push and pop. And after that, whatever method we will create, that is just for our comfortability, our comfort. Whatever method we use, like is empty, is peak element, is top element. These are just the method which we use just for our purposes, for a stack data structure. Okay, but let's see in the slides if we are missing anything. Okay. So yeah, they have given very nice example. They have kept the books one on the top of them. And this book, you can say these books are organized in a stack manner. So you have to first choose the Python, then you have to choose the calculus, then you have to choose the physics, then you have to choose the music, then you have to choose the history. Okay. I think that's what they are explaining. You can see they have also mentioned about LIFO, last in first out. So that's we already discussed it. They have also discussed about the queue. Okay, they are also talking about the queue, you know. But yeah, we will talk about queues in our next class. Why to bring queue here, right? Oh, guys. So in stack, like whatever element comes at the last element, we always say that element is a top position. Okay, because I saw they're mentioning about top, so I thought to bring it here in front of you also. So what is the top? Whatever the last element in the stack. Whatever the last element in the stack. So now you guys tell me where would be our top. And if I take this as indexes, these are the indexes. So now you guys tell me for this scenario, what would be value of my top? Let me come to the chat and let's see. Guys, tell me what would be the value of the top? Yes, top is equal to top is element 3. This element. But the value would be index. Value would be index. So top would be at one position because these are positions. Indexes are positions, right? And top element is the 3, right? Let's see. If we have empty stack, what would be at top? What would be the top value? What would be the value of top? Everyone, if we have empty stack, what would be the value of top? It would be 0 at this index because top always tells us the position where you can insert a new element, where you can insert, or no, where the element, where the, not you can insert, where the element reside, where the element reside, right? So so while creating a stack, we'll keep like by default we'll keep our top as 0. We'll keep our top as 0. Okay. Yeah, top is equal to last element is present. Top is equal to -1. We can take -1 also. We can take 0 also. Okay. We can take -1 also. We can take 0 also. Whatever, like, see top. We can say, see in the, let's see in their example what they are taking, and then we can take about that. They are taking it as a 0, but yes, that's not the case. We can take a 0 or as a as a -1 also. What if top, if one element is inserted? So one element is just inserted, top would be 1. One as the one element will inserted, will bring our top to 1 first index, where the new element will have to insert it. The position where the new element has to insert it. Okay. So earlier the top would be 0. See why we are keeping this variable? Just for tracking. What is the last element which we have inserted? What is the position where the last element has? Correct. So let's see if anything. Let's see if there is any other thing we are missing. Okay. So yeah. So let's do the initialization first. So let's initialize our stack class. Similar like linked list, we'll initialize our stack class. And we will have two default properties, this dot data, this dot top. Top would be 0, as I already explained, the first point where we are going to insert. So they are saying about the top points to the top index of our stack. Points to the top index of our stack. So we can say like the if we simply just want to understand the position where the new element has to insert. The position where the new element has to insert. So that would be our top. And this dot data, where there we will keep all of our information. And you know guys, we can right now you can see we are using array here, but we can also use linked list for creating stack. For keeping the data of a stack, we can use array or we can use the linked list. So you guys tell me when we want to use linked list for a stack. What are the, like, right now we are going to use with the array, but we can also use a linked list for the stack. So what would be the scenarios when we want to use the linked list for a stack, for keeping the data of a stack, when we want to use the linked list? So Likit is saying non-contiguous memory. Okay, that's totally right. When we don't want to access element frequently. Dynamic, yeah, dynamic memory is the, that's right. Non-contiguous dynamic, that's totally right. Because in array, as we know that the memory is fixed, right? So if we want to increase the size of that, we have to just do the lot of operations. So in those scenarios, we will not use the arrays. So in those scenarios, we will use the linked list. But right now, for our example, we are going to use array for keeping the data of stack. Okay. So let's create the structure. Let me go back to chat window. So I already created the stack files. Let me create a new stack file. Then I will delete the earlier one. Stack2.js. Fine. So let's create our class. Class stack. Keep the constructor with the default value. This dot data. Here we do not need to create any node like linked list. Here we are just keeping our data in these places. This dot data is equal to this, and then we are also keeping top. Top is equal to 0. Just to tell where our peak is. If somebody wants to know what is our peak element, we can just find it out through the top. Okay. So that's what we have done the initialization. So if you want to just call the stack, so you want to see let stack is equal to new stack. And if you want to print the stack, we can see the simple object creation. With the class, we create the object. So node stack2.js. I think you can see our stack is ready, where we can insert the data, we can insert the top of. We still have to create the methods here, like push and pop. These are the methods which we need to create, because push is insertion and pop is deletion. These are the methods we will create, and these methods we have to create in a way so they can follow. These methods we have to create in a way so they can follow the stack properties. The stack properties is whenever we are inserting something, it has to come on the top. It has to come on the top. The push method has to work in this way. If we have one stack and already like 4, 5, 6 already has been inserted, and if you are inserting something new like 7, if you are pushing 7, that 7 has to come at the top. The 7 should not come like in the middle or in the before like 4. The 7 has to always come at the top. Understood? And when we are popping out, then 7 only has to delete, not 4, not 5, not 6. So in this way, we have to write our push and pop. Okay. And peak, if somebody is asking about peak element, what is the peak? The peak is the top element in our stack. Peak is the top element in our stack. So 7 is our peak. So we have to write a peak method in a way. So we should return 7 from there. So always, it's very easy. So we just need to return the top element, wherever our top is. We will see based on that. Understood? So till now, everyone understood. First, you guys tell me, did you guys understood? Peak and top are same. Top are property of stack, and peak is the method. Peak is the method of stack. With the help of this method, you can access the property of top, the value of top. With the method peak, you can access the value of top. Understood here? Can you show the code again? Sure. Simply, I created one class where I've just kept the constructor, the default values for that object. And now I'm just going to implement in some minutes push and pop. We will also implement peak method. And we will also implement print method, printing out all of the elements in the stack. I'm just saying Slack because guys, I'm using Slack in my company. So it just like whenever S and ACK is coming, so just automatically Slack is coming in my mind. Yeah. And then print, we'll also use is empty, is our stack is empty. These are some of the methods we can simply create it. So Nilanjan is saying push and pop are predefined methods of stack. Yes, these are predefined methods. Like generalized methods, or yeah, predefined, we can say that. Stack always, whenever you want to create a stack in any of the language, push and pop methods should be there. Okay. Okay. So if I saying, sir, I had one question. Since we are using an array for say storing data, would not be the same push and pop for stack as we use for arrays. Yeah, those would be the same methods. I am trying to create stack data structure in JavaScript with array. With array, I am, see guys, I am trying, see, let's understand. Some people might be confused. We already have, by the way, I already answered this question, push and pop in the array and stack push and pop. Already answered it, but I'm again answering this question because see, I am trying to create a data structure, and that data structure is stack, and that stack data structure has two methods, push and pop. Okay, push mean insertion, pop mean deletion. That's what stack has given to us. Now I am using JavaScript language. Okay, now I am using JavaScript language, and I am trying to create stack with arrays. I am trying to create a stack data structure with arrays. We can create with linked list also. In linked list, we will not have the push and pop method of arrays. Linked list, we have different methods. In linked list, guys, in linked list, we have different methods like insert at end, insert at before, insert at middle. These are linked list methods. In similar way, arrays also has its own methods, which are push and pop in JavaScript. In JavaScript, arrays methods are push and pop. Understood, guys? And coincidentally, the same method stack also has. Coincidentally, same method stack also has. So guys, do not be confused here that the arrays push and pop and stack push and pop, when both are same, why we are creating again push and pop? No. In JavaScript specifically, see, if you want to create a stack in any other language, you will not have push and pop methods of arrays there. If you want to see, guys, just remember one thing. If you want to create a stack data structure in any other language with arrays, you will not have push and pop there. Push and pop for array method, but you will have push and pop for stack. Everyone understood this thing? Because we are creating stack in JavaScript and also with arrays, so we are going to use arrays methods, and coincidentally those arrays methods are also push and pop. Okay, everyone understood? Arad, Hariharan, Suraj, everyone. And let me tell you one more thing. In JavaScript, that's why they have not provided you stack anywhere. If you will go to Java, they have already provided you one stack data structure. They have provided you stack, linked list, everything. But in JavaScript, they have not provided, because with array only, the array you can use as a stack. In JavaScript, you can use array only as a stack. You can use array also. You can use array also as a queue. They have provided that type of method in JavaScript. You do not need to create queue and stack data structure separately. In other languages, you might have to create, you have different like initialization. You have to define, like, as you are right now initializing arrays here, like let array is equal to square bracket. In other languages, in Java, they define stack, they write linked list like that, right? But in JavaScript, you do not need to do that. With array only, you can use this array as a stack, you can use array as a queue also. So implement stack, you always have to use array in JS. Yes, if you want to implement a stack with array, if you want to use stack with linked list, then no need to use array there. Understood, Deepak? We can implement a stack with linked list also. Got it? And linked list, we have already seen a lot of methods, right? In linked list, we were not using array anywhere. If you remember, in linked list, we have not used array anywhere. In linked list, we were using object node. We are creating a new node for data. Okay, you are confused? If you want to speak, you can go for that also. Or if you want to write, I'm okay with that also. Everyone understood? What about others? What about others? You guys are also confused? Can you tell me how many ways we can implement stack in JS? 2 ways. Not in JS only. In any languages. In any languages, you can implement stack with two ways. And those two ways are, you can implement stack with arrays or you can implement stack with linked list. Understood, Deepak? And if you're talking about, I think, yeah, same goes with JavaScript also. In JavaScript, you can implement stack with arrays or linked list. Yeah, tell me, Nilanjan, where you are confused. I think this is not the topic where people should be confused. Yes, there is only two ways. Yeah. So, what was that? Vishal. Yeah. So, Vishal, this is not a topic where, so not Vishal, sorry, Nilanjan. Yeah. Array and stack using pop and push. Yes. So, first, Nilanjan, try to understand array has different methods in different languages, but stack everywhere has pop and push. Everywhere in every language, stack will has push and pop, but array does not have push and pop everywhere. Array has only push and pop in JavaScript. Now, does it make any sense? Does it clear your doubt with this line? Still you have any confusion? Are we good, guys, with the push and pop like clarification? Yeah, I'm not sure JS is superior there or not. I can't say that. But let's not talk about more. Okay, ekdam clear. Okay, so in every language stack is the same. Yes, in every language stack should use the push and pop. So let's implement now, guys. Now we are going to implement stack push method, stack push method in JavaScript with arrays. With arrays. Okay, clear? Now we are going to implement push method of stack in JavaScript with arrays. Okay, so let's see how we are going to implement it. And I will not try to use push here, because in array we can push directly, right? So this would be the push method where we will pass the element, like from here, stack dot push. I want to push 4, right? I want to push 4. So what I will do, I will do this, right? This dot data, this is our array, and I will take this dot top is equal to value. Very simple. And then I will increase my top to plus plus. Done, guys. This is push only in stack. This is only push in stack. Now our push method is done. There is nothing to. There is nothing else we have to do. We can now do multiple push here. You see, stack dot push 4. We can change the number here. 5, 2, 3, 1. It's very easy, guys. Now you know how should this look like in visualization in stack? How does this look like? This should look like this. This first we have pushed what 4. So now 4 should be here. Then 5. 5 should be here. Then 2. Then 3. Then 1. The stack should look like this. Understood? And if you want to print it, so what we need to do? What we need to do here for print, we can take top, because we have to print from starting. So once we can take this dot top, and then we can do while top minus minus greater than 0, जब तक वो 0 से बड़ा है, right? So simply print my element, stack element, and there we can write this dot data and top. Let's print it. देख रहा हूँ पीछे से मैं कर रहा हूँ stack dot print. You see now 1, 3, 2, 5 and 4. Correct, guys? Because 1 is at the top. You can see 1 is at the top. That's how I am showing here. The similar way I am showing here also. 1, 3, 2, 5, 4. And this is our stacks looks like. In the data, we have all the data 4, 5, 2, 3, 1. You can see 4 as 0 index. See, the same stacks looks like this. Stack looks like this. We have top, which is 5. We have data, which looks like this. 4, 5, 2, 3, 1. This is a stack. And if we just do this stack, rotate it, it will look like this. You see, 4, 5, 2, 3, 1. And if you want to access it, we will access always from the top. So now, everyone understood now? Why top is, let me just go from the earlier question first. Sir, once show it pop. Sure, we'll show it. We'll show it. Understood. Okay. Why top is 5? Why top is 5? Okay. Because we have inserted five element, right? We have inserted 5 elements. 1, 2, 3, 4, 5. Right? And now we are saying the fifth index. If you talk about the indexes, you can see 0, 1, 2, 3, 4. Now if you want to, sorry, I've done, see, because of stack, I did the indexes also in a different way. 0, 1, 2, 3, 4. Now 5 is telling this is the next index where you want to insert the next, where you want to do the next push. If you want to do the 7, you can see the push code. What I'm doing in the push code, I'm taking the next stop. So now the next stop would be 5. And then at the fifth index, the new element will be pushed. Understood, Niranjan? But top will be, please show while condition. Please show while condition. Okay, let me first show the while condition. Yeah, this is our while condition. Because our top is 5 and in our array, our elements are from starting from 0, 4, 2, 3, 4. That's why first I did top minus minus. And then I'm checking it has to go till the top minus minus is greater than 0. And then it will go till top becomes 0. And after that, it will stop. Understood? Who has asked this question? Suraj, yeah. Top greater than 0 not getting. Top greater. Okay. That is because of this line. Minus minus actually. Now if we remove this minus minus, now it would be top greater than equal. Let's see, top is equal to top minus 1. Let's see, do we face any problem with that? Okay, so one more time we are coming. Let's see. So top is 5, right? So see, let's see very easily. I think because we have already done top is equal to 0. Okay, so अगर ये नहीं करना चाहते हैं ना, we have to do this top minus 1 here because we need to take, because see this dot top is 5 and in our array we have, okay, let me explain it from here in the visualization. So see Suraj, our array look like this: 4, 5, 2, 3, 1, right? And our top value is 5, correct? Our indexes is 0, 1, 2, 3, 4. अब हमें यहाँ से start करना है, right? So then that's why let top is equal to this dot top minus 1. This dot top minus 1. Correct? Now 4 is coming. Now, where was that code? Yeah, so now 4 is coming. Correct? Now 4 is coming. Now what we did, we printed the fourth element. Then we reduced it. Now 3 will come. 3 is greater than 0. Yes, 3 is greater than 0. 2 is greater than 0. 2 is greater than 0. 1 is greater than 0. 1 is greater than 0. 0 is 0. Yes. Then we did minus 1. And then in minus 1, while loop will stop. And then we will get 1, 2, 3, 4, 5. You see? 1, 2, 3, 4, 5. Earlier, what we did? We did top minus minus. Like this. Top minus minus. Top minus minus will automatically reduce it. We do not need this line. And for 0, because when it will be 1, when it will be 1, it will always do the, this is like already doing the top minus 1. That's why we have reduced it from here. But if it is becoming confusing, then we can do this also. Now, did you understood, Puras? Now with this one, you got it right? Yeah? I understood. Top minus minus 1 was creating problem. Okay, no problem. Let's see next question. The top will be, please show while condition, okay, but top will be 1. Top will be 1. Top will be 5, right? That's the top. You can see in this example, what is top? It's 5, right? This position is 5. Top. Top means सबसे top पे chair कौन सी रखी है? That is top. Position is there, top position is there, top position, yes, top position. Top is representing index. Top greater than 0, okay, that's we already explained. Top plus plus, I think. Yes, top is in, guys, we are increasing top, right? After inserting every element, we are inserting. हमें टॉप पता करना ना. तुमने 3 चेयर रख दी, तुम्हारा टॉप 3 हो गया. Once you put it the top, once you put it the 3 chair, now your top has become 3, right? Because this is the third place where you have to keep the top, and we are starting top from 0, right? So once we insert the first element, we make top as 1. It means at the first position you have to keep it. When we insert the second element, we make our top 2. It means this is the second position where you can keep the next element. That's the top. So okay, got it now. So to print, we should start top from top minus 1. Yes, already did it. Yes, got it. Take top is equal to minus 1 so that our index will also correct in stack. That's also we can do that. Top is equal to minus 1 also will work out there. You mean top is indicating index. Top is actually indicating the definitely it is indicating index. It's also indicating what is the next position where we are going to insert element. That's also it is indicating. For the definition of top, it should point to the last inserted element. Then it will be, then it should go, then we have to start from top is equal to minus 1. If we want to do that from the point to the last inserted element, then we can start from top is equal to minus 1. Then that will work. Top is equal to minus 1 will be the right way. Top is equal to minus 1 will, yeah, in that case, that will be the right way. If you want to insert it. See, do not get confused. We can keep top minus 1 also, minus 0 also. It will work in a similar way. Okay. Could you show the code? Sure, Ankit. Let's see the code. So guys, if you guys are confused using that, we can do the top minus 1 also. And then, this will work similar way. So 0th element, this will print out, this will point to 0th element. First element, this will point out the first element, right? And here in this condition, I think we need to then remove the top minus 1, because now at the fourth, like now we have inserted how many elements? 0, 1, 2, 3, 4. So yeah, I think this will work now. 4 is equal to, yeah, I think it should work. Let's see. 1, 3, 2, 5. So one element is missing. Something greater than equal to 0. Greater than equal to 0. Okay. So top would be what? Top would be 4, right? In this case, top 0 will be here for the 1 minute. When we will insert 4, top will be 0. When we insert 5, top will be 1. When we insert 2, top would be 0, 1, 2, 3, 4. Yeah, top would be 4. So 4 greater than equal to 0. That's okay. It will print out the 4. But it is printing out the undefined. It's not printing out the 1325. I think now we need to do greater than equal to minus 1. Not equal to, greater than -1. Let's see, does it work? Yeah, it should work, right? For 0 also it will print it out, but that's the same condition, right? 4 and 3. So like why it is not printing the fourth index? That's what the problem is. No, it has printed the first index. It has printed the 1. It has printed 3. It has printed 2. Okay, something has been inserted wrongly. -1 got inserted. From where -1 got inserted? Ah, okay. This position also. 1 minute, guys. This position also we need to prove +1, right? Ah, okay. So what we can do the this dot top here. See, somewhere you need to do compromise, right? Now we need to first increase our top, then we need to insert it. That's what the problem is. Let's see. Yeah, now looking good. Now you guys are comfortable? Now everyone is comfortable with this one when we did top is equal to -1. Okay, no problem. Actually, top is the position where element can be readily inserted. And first increment top, then use. Okay, we have already fixed that one. Okay, so now look into the pop one. So I think for pop, the easy way would be, guys, for pop, the easy way would be simply do the pop only. Simply use the array method pop. This would be the easy way. This dot data dot pop, and then do the this dot top -1. Okay, but yeah, before that, we should check something else, some more thing here. We should check one more thing. So in stack, I'm now right now talking about stack, guys, not array or anything. Now I'm talking about stack. Stack has two type of problems. Stack has two type of problems. One is called overflow, and second one is called underflow. Okay, in some interviews, like in the very basic interviews, if you're in the college, so people can ask what is underflow, what is, yeah, overflow in stack, and what is underflow in stack. So overflow is because in JavaScript it will not overflow, because JavaScript, I'm now guys talking about JavaScript specifically. In JavaScript, array is very dynamic. You can just keep lot of element in array. But in the Java, when you create an array, you define size. You define size that in an array only 10 element will be inserted. In Java, when you create a new array, you tell the size there that in this array only 10 elements will be inserted. So right, so whenever you have provided some size, and when you want to insert more element than that, then stack will throw overflow error. Then stack will throw overflow error. So the meaning is very simple. When you have limited size and you want to insert more than that, then stack should throw the overflow error. And about the underflow, when you want to delete something, when a stack is already empty, when a stack is already empty, and you want to still, you want to still, you are trying to delete it, it should throw underflow error. It should throw underflow error. In stack, if you have 10 element size, and if you're trying to insert 11th element, then it should throw overflow error. And when you have empty stack, at that time, if somebody is trying to pop it out, somebody want to delete something, you should throw underflow error. Everyone understood overflow and underflow? Everyone understood overflow and underflow? So in, because we are trying right now stack with JavaScript, so overflow will not happen. Overflow will not happen. So Nilanjan, overflow is when you have size of an array as 10. So you can only insert 10 elements, right? But you want to try to insert, or you are trying to insert the 11th element also. So at that time, our stack should throw overflow error. This is overflow. Okay. And about the underflow, if you do not have anything in the stack and you are trying to delete it, then your stack should throw underflow error. Understood, Nilanjan? Yeah. Now in JavaScript, we have dynamic array, right? So it can take a lot of size. So in JavaScript, I'm not sure if we will get any overflow error. But yeah, for underflow, we can definitely check. For underflow, we can definitely check, and we can first create the isEmpty method. We can create isEmpty method earlier, and then we can, yes, that's totally true. That would be underflow condition. So now for empty, when our stack will be empty? When our top is -1, right guys? क्योंकि हमने देखो top क्या insert, top हमने start किया है -1 से. So when our top is -1, it means stack is empty. Am I right, guys? Everyone agreed on that? If top is equal to -1, it means our stack is empty. Agree? So what we can do here, we can simply in our isEmpty method, we can simply return top is equal to -1. This dot top is equal to -1. अगर ये -1 होगा, if it is -1, it will return true. Otherwise, it will return false. Agree, guys? Return this dot top is equal to -1. If it will be true, if our top is -1, it will return true. Otherwise, it will return false. Right, guys? Everyone agree with the isEmpty method? Correct? Let's use this method while checking our pop element. So we'll see if this dot empty is empty. If it is giving true, if it is giving true, we can simply return this is underflow situation. This is underflow situation. We can't pop it. We can't pop it. Pop it. Right, guys? Because our stack is already empty, and then you are still trying to pop it. So what will be there? It will be, we cannot pop it, and we can keep the other part. No, we do not need to else. We do not need to keep the else here because already we are returning from here, so it will not go into these lines, right? Understood, guys? Understood our pop method also? This is our code for, and we have already done top minus, yeah, that's also right. Already done the top plus. This is our code for push. Now, if you want to, for the peak element, we can simply return this dot top from the peak because this is our only peak element. Want to check anything here is empty or something, we can check also. Otherwise, this dot top is also fine. Okay. Or if you want to see elements on the top, then also that's fine. We can do this dot data. If you want to see the top element, so this dot data, this dot top. This will return the element from here. Understood? So sir, isEmpty is also a predefined function. isEmpty is also a predefined function. I'm not sure about that, but push and pop, I remember it should be with stack. But about the isEmpty or peak, these are user-defined methods. Yes, these are user-defined methods. Okay. These are user-defined methods. Then how it checks for empty stack? Yeah, that's what I'm saying. We can create our these methods. We can create these methods. If somebody wants to create a stack, they can create the empty methods also. They can create isEmpty method also. Okay, Linjan? As we have created. Please explain pop. I lose my network. Okay. So in pop, what I did, Suraj, first I am checking is my stack is empty or not. So once I check my stack is empty, and how I'm checking that, I'm checking from here. If my top is equal to -1, it means it's empty. And if not, then we will simply delete that element. This dot data dot pop. It's simple array method. From the array, how can we delete the element? So this dot data dot pop, and then when then this dot top minus minus. Understood? Who was asking that? Suraj, yeah. So we use it to check for empty stack so that we can throw specific conditions or error like it's yes in empty. So we just simply use our is empty method to internally check things. Internally check things like underflow errors, these type of errors. So this dot pop will automatically remove top element. Yes, from the stack it will remove the top elements. Totally right. Totally right here. Top element, not the bottom one. Totally right. In the stack, we have top and bottom. Bottom is the line, like the last element. So pop will always remove the top element. Okay. Let's see if there is any other method which we have missed. Initialization is there, push is there, is empty is there, pop is there, overflow, underflow. We have already discussed. Let's see. So this was their constructor. In the linked list, they have taken this as a constructor. This is push. This is push. Already we have pushed like that, but we made our top as -1. So no need to do that like that now. Then we have is empty method. We have not implemented it here. Then we have our pop element. So first they are reducing the pop, then they are deleting it, and then they are checking also if this dot is empty, is equal to false. That's fine. Yeah. Then let's see what else they have. Overflow, they are explaining it. Underflow, they are explaining it. They are writing the condition in pop for that. They are throwing the error. We can also throw the error actually. Yeah, this is good. Rather than returning it, we can simply throw the error here. So new error, underflow stack. You know, when the JavaScript, if you remember earlier class of us, when we were talking about the Node.js, 1 minute, yeah. When we were talking about the Node.js, you know, you remember that? About the, I told you that in the JavaScript, in the browsers, we have call stack. Remember in the call stack, I told you, that's also uses the same stack, where all the JavaScript function goes and they run it there. Just use this same stack. Dinner break, okay, need break. Let me just go through 1 minute. I think we have already covered everything. Now we can simply jump into the problems. Let me see if we have missed anything. Just quickly. Underflow already explained. Peak, what they are doing? Yeah, they are saying if this is empty, return null. Otherwise, simply return the element. That's what we are also doing. In the peak, you can see, I'm not checking the empty condition. I'm just simply returning the element. Yeah, but we should check because now we are returning the element. And this top could be -1 also. This top could be -1. So yes, we should check this element, this condition also. If our stack is empty, and we should not throw the underflow, we should not throw the error now. We should simply throw the we should simply return the null, right? We should simply return the null. If our stack is empty, so our peak will give us the return null. Otherwise, peak will give us the top element. Whatever element is at the top, that's what the peak is here. Okay, guys. So just these are some user-defined methods. Might be stack, might be having them. Then print, we already done the print. Yeah, I think then we will start on the problems. Yeah. So meanwhile, let me see if you guys have any questions. So yes, what is use peak or what is peak? Peak means top element. In the stack, whatever the element is on the top, that is our peak element. Can you implement that pop function for me? It's not working. For me, you mean implement that pop function? You want to see the code, right? That's the code. You want me to push the code? I can push that. Let me push it, this guys. And this code is going to be in stack branch. Okay. Let me commit it. Stack changes. Okay. What I missed? Oh, space. Yeah. These changes are going to be in the, oh, you want me to run it? Okay. So let's run it, guys. So we have pushed these many elements, then we have printed it out. Let's run the stack.pop. Okay. Let's pop 2 elements from our top. Yeah. And then print it again. Okay. Let's run it. So guys, you see, first we have done, first we have printed out all the inserted element, which were 1, 2, 1, 3, 2, 5, 4. Then we did the pop 2 times. You can see 1, 3 has been removed. Let me do the console also. Console, one more, console.log. And after deleting, yeah, now we will be able to understand properly. Yeah, after deleting, you can see 254 is coming here, and are in the stack data we can see only 452 two elements, and top is at second position, which is the peak element. Understood, guys? Okay, now we can go for break, and then we can look for some of the problems which we has in the. I hope everyone had understood. It was not very difficult. Stack and queue are not that much difficult. We are going to use the arrays method only. For implementing stack and queues data structure, we are going to use. Today's problems are only easy one. Whatever problem we will do today, those are easy. But the next class, whatever the problem we has, like next greatest element or next greatest element to right, or next greatest element to left, next lowest element to left, next lowest element to last. Those are very interesting questions, and in a lot of interviews they ask those questions. Those are only questions actually in lead code also. Those questions are there. We'll talk about them. And there is one more histogram problem is there. There is a stock span is there. These type of problems they are already in the slide. So those problems in interview they ask, they comes from the stack only. Yes, we have finished the linked list. You guys have to know, practice the problems. Yes, we have finished from the course wise, but now you have to practice it. Okay. So Likhit has getting the wrong answer. So let's see his one. So he has pushed 9654, and then he did print, then he did 2 times 4. So 4596. Okay, so pop is not working in his im. Pop is there. This data dot pop. By the way, where is your is empty method? Likhit, where is your is empty method? Can you share the screenshot where you have created the is empty method? Others can go for break. So it's 9:37. They could come back at 9:53, right? That's a 15-minute break. Yeah. Others can go for break now. I'm not going to talk any new thing.
if this dot top is not equal to -1, return true. Is this top is not equal to -1, return false. That's the wrong condition. Is this the top is not equal to -1? Okay, I kept, yeah, you kept the wrong one. Just correct that one and test it. Great. That was the only problem. Okay, so let's come back at 9:53, guys. Okay.
Is everyone back? Great. What about other? Okay. Okay, so let's jump into the questions, guys. In stack, these are little bit like the easy wise. Here you will be mostly using push and pop, little bit recursion, those things. Okay. So let's jump into first question of it. So everyone back, right? Let's wait for 1 more minute. Otherwise, somebody will back and I need to repeat it again. Just write in the chat if everyone is back. Okay. Hariharan, you are back? I think still some people are not back. That's fine. How many your office work? So it's start from 9 or sometime 10, and then it ends on 5 o'clock, sometimes 6 o'clock. I also have one meeting at 6:30. So sometime I end it at 5 o'clock mostly. And I just go for running, I think for 45 minutes after 5 o'clock. And then I think I had one meeting at 6:30. Yes, I'm working from home still. So yeah, 9 to 5. But yeah, I generally start with 10 o'clock and then it goes to little bit 6. Money saving mode. Yes, why not? But yeah, actually less exposure, like less exposure, because when you are in office, you have very different, environment. I'm truly speaking because I have worked more than I think 4 years. Yeah, 3.5 years in office, total, and somehow with God grace, I got a lot of good teams. I learned a lot from them. Totally different. If somebody is new, I would say that please go to offices. That's totally nice because you will learn a lot of things. Lot of things. Okay, so product-based companies have flexible timings, right? Yeah, like service-based companies also have flexible timings, but that depends on your team, and again, team mostly depend on teams. Okay, so let's jump back. Now Hariharan joins. So we have waited till Hariharan joined. Okay, great. So let's see first of our question, guys, which I think some people can guess it, but let's see. The first question is insert element at bottom. So you guys know that in the stack how the insertion happen. If somebody wants to insert something, if this is our stack, and in that stack, if we have already inserted 4, 3, 2, and 1, now what is the next position where we can insert? That is this one, right? Where we can insert? Top will be at this place. Correct, guys? So now, if we want to insert 4, now we want to create a one function, insert at bottom. Insert at bottom. So if somebody wants to insert at this place, what is the approach he has to take here? If somebody wants to insert
at this place, what approach he has to take. Let me, I will give you some time to you guys to think about it. If somebody wants to insert in the stack, just think about a stack right now, not in the arrays or anything like that. In the stack, or stack has only how many methods? I think by default push and pop. These two methods they have. So with the help of these two methods, or you can include also is empty or peek. With these four methods, if you want to insert at bottom, how will you do that? Any ideas? So now Likhit is giving first idea. So let's read. Every element index must be incremented by 1 and top is equal to top plus 1 and add element at 0. But how we will add element at 0? Because push is only inserting it at the first position. Understood? You are thinking it as a array. Do not think it as a array. Think it as a stack data structure. Okay, so let's see Nilanjan idea. So insert at bottom. Do we need to push all upper element to upper? Upper element to upper. So guys, let's take this example. We have 7 chair. We have 7 chair here, which are on top of each other. Okay. Now you want to insert a chair at the bottom. You want to insert a chair at the bottom. Understood? Now we have 7 chair, like chair 1, chair 2, chair 3, chair 4, chair 4, chair 5, chair 6, chair 7. At the chair 1 position, you want to insert a new chair. So that's the question. How we will do that? Understood? Now everyone understood the question? Okay, so now let's see. Vishal is saying shift area every element after the one that's to be inserted at next index. So shift every element after the one. So again, you are giving answer in the arrays concept. Okay, I'm telling we only have 4 methods. Pop, push, is peek, peek and is empty. These are only 4 methods which we can apply. Let's see, Likhit has given one more answer. Okay, then pop until last element and insert our element and push all remaining element. Yeah, right now Likhit has given close, little bit closer answer, right? He has given answer little bit closer to that. That's totally like close to our answer. Okay, that's what we are. So guys, Likhit has given the answer. Now let's think about it. Now he's saying, yes, we have to pop each element till last element and then insert our element, all remaining element in again into the stack. That's totally right? Okay, let's see. We will come back into that. Let's read others' point also. Parag is saying all elements at the top of new will help in insertion. All elements at the top of new will help in insertion. Not sure, and I didn't understand properly. Second approach will work. Yeah, second approach will definitely will help us. We can pop and push that new element one by one. Yeah, that's what I think Likhit is also saying. We have to use the pop and push, but what way? Okay. Haryana is saying this data top is equal to this data top plus 1. This data top is equal to this data top. No, you are giving answer in arrays. Haryana, you are giving answer in the arrays terms. No, that's not the correct way. I'm saying we do not have arrays here. Think about this stack. Okay, so now Parag is saying we'll lift 7 chair and place over new. Yeah, that could be another answer. That could be another answer that we create a. See, that's a similar thing which Likhit is saying. But yeah, we can say this could be what he's saying. What you are doing. You are creating a new stack, and in that stack you have already inserted element. Then from the older stack you are trying to insert one element one by one, popping it from there, pushing into the new one, popping it from there, pushing it into the new one, popping it from there. Like तुमने एक नया प्लेस चूज किया, वहां अपनी न्यू चेयर रखी सबसे नीचे, इसके बाद पुरानी जो चेयर रखी थी उसमें से एक एक को पॉप किया, डालते गए, पॉप किया, डालते गए. दैट्स व्हाट यू आर सेइंग पराग. बिकॉज ऑल 7 एलिमेंट्स को उठाना, that so or yeah, that could be also answer. See guys, that could be also answer कि all 7 chairs को उठाया means हमने क्या किया, एक नया stack create किया. We have created, see, this could be one answer, this could be one answer. See, we have like this, right? See guys, this could be one answer. 4 3 2 1, ये 4 एलिमेंट्स थे, हमने एक नया स्टैक क्रिएट किया, one new stack. We just started popping it out. So pop, I'm just writing the method. Pop, ये stack 1 है, stack 1, ये stack 2, right? So pop, pop from stack 1. So stack 1 dot pop. So now the first element will come 1, and then we can take this element. We can take this element and insert into this one. 1, right? It will be gone from here. Then 2, like second time pop, st2 dot pop, right? Second element gone. Then third, then fourth, and then all would be inserted here in another pop, another this one, 3 4, right? And then we can insert the new one, which is 0, and then one by one from here we can start again from stack 2. We start popping it out and pushing it into here. 4 3 2 1. That is correct answer. That could be one way. That could be one way to do that. I think it's totally similar to the Likhit, which Likhit has given answer. Okay. But now you can see in this way we have to create a new stack. New stack. Is there a way without creating a new stack we can do this? Is there a way without creating a new stack we can do that? Let's see. Meanwhile, read other answer also. First, remove all element. If reach index element, we push. Yeah, that's what we did. Now I'm thinking, that's right, Suraj. That's what we are doing. Can pop top element. Anand is saying can pop top element and push new element one by one. Goes at bottom index. I think that's what we did, right? By swapping, I guess. No. Swapping is also not there. So guys, here we will use the recursion. Here we will use the recursion. So now what we will do guys, first we will take our top element. First we will take our top element, which is 1. Let's just rewrite our rewrite our array, our stack. This is 4, this is 3, this is 2, this is 1. We'll create one recursion function, because when we how the recursion function work? So like recursion A is there, right? And then in recursion function A we put the base condition. We write our base condition where our recursion will stop, and then recursion will automatically call it. Like we'll call the same recursion method again. Correct? And how this recursion work in the real scenario? Like in the real scenario means how this recursion work? So first we'll call the recursion A. Of whatever memory it has, it will be included with this. Like this is the memory of recursion first method. Then the second recursion method. Like base condition is still failed, so we are again calling recursion A. Then it has his own memory. Like I'm just giving recursion 1, recursion 2, this is memory 2. Then there is recursion 3, third time. Base condition again got failed, so we are again calling recursion. Third time, third memory. Then the recursion 4, and now we can say our base condition got passed. So we will stop here and then we will start moving back. That's how the recursion works. And then we will reach at the first time where we called. First time we called, second time, third time, fourth time. We have only called first time, but automatically because our base condition got failed, base condition failed, So अपने आप उसने कॉल किया. Again, base condition failed. I'm just writing BCF. Base condition failed. Did you see now the solution? Why I'm writing memory 1, memory 2, memory 3, memory 4? Because in this memory, we will now keep our elements. Once we will popping out in this place, we are going to keep our memory. And then when we will be going back, we will be having these separate memories. Separate memories mean these elements at that place. We do not need to use any new stack or any new data structure for storing these data when we are popping it out. So we can use the recursion strategy. In recursion, every time a new memory will be called when a new when a new function get called. So at that time we can keep the memory. Okay, so sir, as I just earlier, can we push all elements to one position? So that one new element will get inserted into empty space without using extra stack. Can you push all element to one position? At one position, only one element can be pushed, right, Nilanjan? At one position, only one element can be pushed. So we can't push all elements at one position. So that one new element will get inserted into empty space without using extra space. It means you are saying about the new space only. Okay, so that's how the code is going to work, guys. Okay, so see how will this work? So first we'll take our first element, 1. We'll keep like our function. I'm just writing as a function, as a recursion function, as a insert at bottom. Our base condition would be here when our stack is empty. When our stack is empty, I told you, right? We have to use only these 4 methods. So when our stack is empty, this is our base condition. And till जब तक हमारा stack empty नहीं है, हम same काम करते रहेंगे. We will do all these things. So first we'll take the top element. So top element would be 1. So like top element would be like, we can take one variable here for keeping the memory. So it would be similar to like temp. We'll keep first 1, right? Then we will pop this dot stack dot pop. Correct? We'll pop it. After popping it out, we'll again call the same method, insert at bottom. So this dot, insert at bottom. We'll again call it, insert at bottom. Okay, we'll again call it. Now, first time we called, this M1 will have 1. Correct? Second time we called recursion. Again, now temp will become next element, next top, which is 2. Next top will be 2. So now we'll keep the 2 here. Again, our stack is not empty. Now our top is at 3 place. So now temp will become 3. Temp will become 3. So now we'll take 3 at this place. Again, now our top is, again stack is not empty. So now temp will become 4. Temp will kill 4. Now, once now stack is empty, now this call will be returned. Now this call will be coming at next place. Now like this function will be start returning. This function will be start returning. So once this function is start returning, it means now our stack is empty, guys. Now our stack is empty, right? There is nothing in this function. So what we can do, I think I missed one more thing. I think we can correct it here. Because we want to insert the element, right? So what we can do here, we can keep all these things in else. Okay, let me just write it again. Guys, let me keep all these things in else. If stack is not empty, do all these things like this dot top. Do all these things. If our stack is empty, then stack dot push. And this will only happen when our stack is empty and we will insert the new element. जो भी new element हमें bottom पे insert करना है, we'll insert it here. Stack dot push. And then once the element is pushed, when the stack is empty, it will come back here. we'll simply return or no need to return also. We'll just simply this is stack dot push, and then we will start inserting this temp element. So this dot stack dot push temp. So जैसे ही stack empty हुआ, as our stack is empty, right? So first we will push 0 there in this condition, then it will come back to this line, because till now we were calling this line only, this dot insert at bottom every time. So it has started the new call. It has started the new call. But now, once this call is completed, because our stack is empty, we are returning something else. We can return some empty from here. It means this call is completed now. This call is completed now. Now it will go to this line and we'll start inserting this element 4, 3, 2, 1. So now after 0, 4 will be inserted, 3 will be inserted, 2 will be inserted, and 1 will be inserted. It's very simple recursion. And I hope I know that you guys have already completed the recursion. So this would not be very difficult for you guys. Right? Let's see first queries from starting. Yes, sir, I mean pushing element to one new space so that one empty space can be. So pushing element to new space, that's same like, right? The earlier scenario, the hash one, the same hash one, right? The same, sorry, stack one, where we created a new stack. So that is similar, right, Niranjan? Why create temp? So temp is the memory in each function. This is simple variable which each function has. You can see each function has this function. Every time this is the new function, new variable. Let temp is equal to this dot temp. Every time new function has new variable. You know, in JavaScript, block scope. Every time we create a new, every time we call the function, it will create a new memory. That's what I'm representing that temp as here. New memory. You see, this temp is a new memory. Understood? Who was asking? Suraj, understood Suraj? Yeah. Temp is incremented every time. Temp is incremented. No. Temp, we are not incrementing. This is no. We are not incrementing it. We are just taking the top value. You know, Joseph, we are doing stack.pop. What we were doing in the stack.pop. You remember stack.pop method? We are automatically reducing our top. So it is happening in stack.pop. We are always taking the top element. Understood, Joseph? Okay. Let's see the next one. Please explain insert at bottom. Which part in insert at bottom? Or I will explain the function again, but if you have any specific thing, Suraj, you can talk about it. Okay, so temp will be changed as per the recursion stack. Yes, temp is a variable in a function. So every time a new function will be invoked, new memory will be invoked for that function. Okay. Who was asking? Hariran. Okay, understood, Hariran? Every time a new function will be invoked, new temp variable will be invoked because new memory is going to invoke for that. Okay. We have to push this data dot temp. This data temp. Okay, this data temp. Where is asking this data dot temp? This data dot temp. No, that will happen with the push only, right? If you will do the push, that's what happening in push, right? This data, this dot top. Automatically that is happening, right? If you will do the push, automatically top will change and everything will change there, right? Let's see next thing. We store values in every function called temp. Yes, we store in every function. We are just creating a new variable and storing the new value. That's totally right. Totally. But after removing all elements from a stack, that will not work. So we have to take value in temp. Yes, that's why we are taking the values in temp. And then once the stack is empty, so first we will insert the new value. And then whatever we have stored in the temp, then we are again going to insert them back. Okay. We are talking top in temp. Top in temp. Okay. You are talking about this one. That's right. We can take here peak also. This dot peak. That will give us, right? This dot peak. That this dot peak will give us, right? This dot peak method will always give the peak element. Yeah, that we also use. Recursion will use ON auxiliary space. Yeah, space, if you're talking about the space, so definitely recursion is going to take a space also. Yeah, recursion take space, yes. And if you talk about the auxiliary space, that I have to think about, because recursion takes more space than the iterative approach. I'm sure about that, because in the call stack, those functions are going to stay, right? Those functions are going to stay. So definitely the space will be there. But let me check. Let me check that part. How much space it is going to take. Let me check if they have given in the scenario. Let me generally search it. Calling recursion. Space complexity. To conclude, recursion algorithm is proportional to maximum depth of recursion tree generated. Okay. If each function call of recursive algorithm takes OM space, and if the maximum depth of recursion tree is n, then space complexity of recursion algorithm would be O n n n comma n n comma m. So take OM space, let trees n. So we can say in our case, how much how deep we are going into the recursion tree. How deep we are going into the recursion tree? Let's see in the diagram. So I think it's 1, 2, 3, 4. So yeah, I think it would be equal to the elements, number of elements. Yes, that's totally right. It is going to take the ON space also. Totally right. Take element value. Okay. So I'm not getting why we change from top to peak. From top to peak. Ah, okay. So Hariharan, top was giving us index. Hariharan, top, you see in the in the code, top was giving us index, and we do not want to take the index. We want to take the element. Peak is giving us element. We want to take these elements 4, 3, 2, comma 1. We want to take that element. So that's why we move from there to here. What is the auxiliary space, temporary space? So like it's similar, like how much space it is going to take in the memory. So that's the space. Recursion will be taking only auxiliary space in this case. I'm also not sure about the difference properly about the auxiliary space and temporary space, but I will read about it and I can answer this question later. Okay. We need element. Okay, that's already answered. So we change that. Auxiliaries. Vishal is saying auxiliary space is a temporary one. It's not the it's not like the permanent one. So it looks like when we create a map or arrays, they have the permanent space in the memory. But it looks like these functions, they just create the auxiliary space. It means temporary space for some time. So what I understood with auxiliaries, but yes, I can read about it and then come back with better example. Yeah. Was confusion. Sure, no problem. I will just look into that one. If somebody is already aware of it properly with good example, he can write it here. I think Vishal has some ideas. So Vishal, if you have some more ideas, please write it about here. Otherwise, I will look into that one. Okay. And we can talk about it in the next class. So can you explain the recursion process again? I was confused in that. Okay. So let's run it. Let's do it here. So insert at bottom. Let's run it here. Insert at bottom. It will take one value, correct? Right? And then there would be first condition. If this dot is empty, right? This would be the base condition where we are saying that our stack is empty right now. Our stack is totally empty. If our stack is empty, simply this dot stack dot push the new value, correct? The new value from here, and then simply return, or we can check that we need to write return or not, but we can check. Return is also fine, that's fine. We can write the return. And then in else part, if our stack is not empty, what we need to do? If our stack is not empty, we need to pop all those elements one by one, correct? And we have to keep all these elements at one place, one variable, and that variable we have created as a let temp, right? Let temp is equal to this dot peak, or yeah, I think peak will also give you the top element, right? And then we were calling the same insert at bottom again with the value, correct? Once this call will be completed, and once we got the return, I think this return, could it be return? No. Okay, this return will come back here only. Yeah, this return will come back here, and then we can call this dot stack dot push and temp. Whatever the temp variable, we are storing it in each of recursion calls here. In each of recursion call here, those will be pushing it back into the stack. Let's run it and test it if we are facing any problem here. Okay. And at the end, we are already calling the print, so no problem with that. Let's remove the pop method for comment it out for some minute. And this is like before, we are printing it before that and after inserting. After inserting new at bottom. We'll do it here at bottom. Let's insert it. Stack dot insert element at bottom. Let's insert 0. Let's see if we are facing any problem with that. Flag dot print. Let's see. Okay, so we are getting some error. Insert element is not a function. Okay, what is this then? If it's not a function. Insert at bottom. Oh, element at bottom. Oh, I've taken the wrong name. Insert at bottom is the method. Okay, so now we got some error is empty. Maximum call. So somewhere some condition is wrong for us. Maximum call is stack size into if this dot is empty. Return this dot this dot stack dot push value. Return. So is empty maximum call. So somehow, somewhere our stack is not stopping. Or what could be the reason for that? Oh, we are not popping out. Sorry. We have missed the important step. We were not popping it out. This dot, oh, why are we writing stack? This dot pop. And why we are writing stack? That's weird, right? We are using the same method, right? Same class. So this dot push and this dot pop will work. Yeah, let's see it now. Again, cannot read property of this dot stack dot push value. This dot stack dot push value. Oh, stack again. Why we are writing stack? Okay, yeah, guys. So let's see. Before inserting, this was look like this: 1 3 2 5 4 from the top, and now you can see 1 3 2 5 0 2 5 4 0 at the end. Now you can see at the bottom we got the 0. Right, guys? Yeah, actually, I was missing a lot of things there. We have to reduce top by 1 also, I think. Vishal, those reducing and increment thing is already happening when we are doing the popping, when we are doing the pushing. All those things are already happening. Understood? Who was asking? Vishal? Understood, Vishal? Okay, so return will stop function executing, right? Yeah, function execution will be written. That's right. Who was asking that? Hariharan, yeah. Stop line 42 also. Yeah, I corrected it. I think you guys are talking about the correction. Yeah, I corrected that. Line 43 return. One stop function execution. Line number 43. It will stop, right? Dry run for us. I'm confused. Dry run. Okay. Okay. Please explain X part. Can you explain the recursion part? Okay. Guys, let's see it again. This is our array. This is sorry. This is our stack. 4, 3, 2, 1. 4 element this stack has. So what we did, we have created one recursion function, right? And that recursion function name was insert at bottom, correct? And we were passing one value from there, which we want to insert at this place, at this bottom, correct? So what we did, we have written one. So what we need to do, guys, we need to pop all these elements because we want to insert a new value at the bottom. Okay, so what we did for pop, we have taken one variable here. Let temp is equal to this dot peak. It will always give us peak element, which is 1 in this case, correct? And then we did this dot pop. So once we did once we run this line, now our stack become like this: 2, 3, and 4. This was after first recursion call. Now, right now, I'm just also creating the recursion tree. So this is first recursion is happening. Inserted at bottom. First time we call the recursion. Correct? Like here. You can see this is the call. This is the first time we are calling insertion at bottom. Correct? So now this is the first call. I'm writing it as the first. Now inside this all things are happening. We have created one temp variable here also. Inside this function, we created temp, which is having top, which is 1. Correct? Now this dot pop. Now what we did, we again call the same method. This dot insert at bottom. We again call the same method. Correct? And once we are calling this method, this call will be invoked. It will not go to next line. It will not go to next line till this call will be completed. Till this call will be completed. That's how recursion works. Till this call will be completed, it will not go into next line. So once we call this function again, it has called again insert at bottom. It has called again insert at bottom. Second time. Again, it does the temp word, temp. It has created new temp variable here, which has new value, which has 2. Again, we did the pop. So now our pop has 3 and 4 only in stack. And again, you can see, again, I called this insert at bottom. And when we are stopping this thing, we are only stopping it if our stack is empty. We are going to only stop this call when our stack is empty. Else, we are going to call it again. So now, third time, insert at bottom, third time. Okay, this is third time. Again, new temp variable has created for this function, which is going to keep 3. Right? Again, new fourth time. So once we now here stack only has right now 4 because the last element. Now again 4 time insert at bottom. Correct? Now temp is 4. Again pop happened. Now our stack is empty. Again call we insert at bottom. 5th time. Correct, guys? 5th time. But this time our stack is empty. It will go into this condition, if condition. Correct, guys? Till now, are we good? Till now, are we good? Everyone? Till now, are we good? Now we are in the if condition because our stack is empty. What we did? Now we did stack nahi. This dot push. Guys, wherever I'm writing stack, you know that, right? Here I have to write this because I'm calling in the same class, right? This dot stack or this dot push, right? And here we will push the new element which we got. So now once we do this line and then we are doing return. So now once we do this dot push, Now stack, this empty stack again have one value, which is 0, which we are trying to insert. Now this has return. Now this function call is called returning it. So now once it is returning, it will come back to this function. It will come back to this function. And now in this function, after this line, whatever we have written, it will be executed. So after this line, whatever is written at the fourth function call, whatever is written, that will be executed. And what we are writing here, this dot push temp. जो भी फोर्थ पोजीशन पे टेम्प है उसको इंसर्ट कर दो. Whatever temp is in the fourth position, just insert it. So now after 0, 4 will be inserted. Then we will return back to this one. Third inserted again this call. For the third function. Again, this line will be returned. This line will be running. Now temp is 3. Now 3 will be coming here. Same goes for 2. Same goes for 1. And our function's call will be stop here. After this line, nothing is there, it will stop. And then we got our final stack here with the newly inserted element. Is it clear for everyone? We can use it, or if we are not using it, will still stop it. We can use it after this also. Because after that, nothing there, so it will not go there. It will automatically return it. Okay, Joseph? It will automatically go out of that function. Okay. So I hope everyone understood the code. So next code is very similar to that. Next code is also going to use the similar thing. And next code is reverse element in stack. It is automatically done. Yes. Sir, you can also share this explanation page. Which one? This one. How will I share this thing? You guys want to take the screenshot or picture? That would be better, right? You guys can take it for this thing. If you guys want to take the picture, something like that, so you guys can take it right now. Share it as a PDF. Okay, I will look into this one. Yeah, I will look into this one because this is actually a little bit specific to this document is specific to PayPal. So I'll have to check that one and then we can come back. So after return, how it is invoking? After return, so Parag is asking, so after return, how it is, that's also, how after return, how it is input. So after return, it will go to next line. अभी भी तो connection है ना ये. These connections are already there. These connections are already there. These are just the invoking is happening. So once it is not getting any other line, it will go for next line, right? How the JavaScript works? JavaScript works line by line, right? First console happen. Sorry for that, siren is coming there. Then x is equal to 4 plus 5 will happen, right? Then again console will happen. So this console, until we get the result of this console, we will not go to this line, right? That's how the internal compiler work, right? That's how the internal compiler work. So till now, once we will execute this whole function, we will not go to the next line. Understood? Who was asking? Parag? Understood, Parag? Once that function call will not be completed, will not go into the next line. And once that function call is completed, then now we'll go to the next line. Yes, after return or JavaScript automatically understand that if there is no other line, it means we have to stop the execution. Okay. Yeah, but better way is we have to write the return. So we can like easily we are telling that this function is ending. Now you can go for the previous call from where you have invoked this one. Another line for temp. Yes, after return it's another line for temp. You have a lot of temp already there. Lot of temp already there. And those all temp are specific to each function, right? Correct. Those all temp are specific to that function, whichever we are invoking. So once that function is closed, that temp will also close. Correct? Once we are invoking a new function, new temp is created. Once we are closing the function, that temp is also deleted for that function. That is like at the JavaScript level things are working. Yeah, we are getting new temp every time. You see this let temp, it means whenever we are doing let temp, it means we are getting a new variable, right? Every time. Yeah. Okay, got it. Okay. So guys, so next question for us is very easy, like relatable, which is reverse element in stack. Now, what we need to do, I think very relatable. We have one stack. Same stack we can take 4, 3, 2, 1, and we need to reverse it. So it should be like this: 1, 2, 3, and 4. And we have to use the same approach actually. We have to use only these methods: push, pop, peek, and what was the next? Is empty, with the help of these methods. And now we can use this new method also. If you guys think about it, insert at bottom. This method also we can use. Any idea? Now we have already seen the recursion also. I'm just telling we are going to follow the same approach. We're going to use these methods only. Any idea now? You guys want to think about? Let's think about it. Let's give 2 to 3 minutes and let's think about it. Okay. Let won't allow to redeclare, but how it is working in this? We are not redeclaring it. Likhit. We are creating a new function. New function means new. It's something. It's totally new. Whenever we are invoking a new function, it's totally new space. It's not we are doing in the same space. So push temp before recursion. Okay. So Sarad is saying, Sarad has start giving suggestion for the reverse scenario. Push temp before recursion. Push temp before recursion. So what will happen? You are popping and pushing. So like if you're popping one and pushing it back in the same stack, what is the change here? Sharad, you have popped it out first. How the inserted bottom was working? You have popped it first and then you are pushing it back. No. We don't want to create a new stack, Deepak. That's what the reason. That's what we don't want to create a new stack. We want to do something with this only. With new stack, that's very easy. We can simply pop it out and push it out. Push it in the new stack. Harian is saying first pop them and insert at bottom and push. Yes. Something related to that. Hariharan has given right answer. So first pop them and then insert them at the bottom. That's very nice thing. And push is not needed then. Guys, think about it. Hariharan has totally said correctly. First pop the item. See, very nicely Hariharan said. So first pop the item. So you have popped out 1, right? You have popped out 1. Then you popped out 2. Then you popped out 3. Then you popped out 4. Now your recursion is ending here. Your recursion is ending here. Now you have to go back. Now next line will be running. So now at the temp, at the last function, temp would be 4. So insert this 4 at the last position. Insert at bottom. So our stack is right now empty. So now 4 will be inserted here. Right? Now this call will go back for 3. Now 3 will be inserted. But 3 will be inserted at bottom. So 3 will be inserted here. Now it will go for 2. For 2. And now it will be inserted at bottom. Totally right. Hariharan has said it correctly. Now at the 1, 2, 3, and 4. That's how the reverse will happen. Totally right. Pop and insert element at bottom recursively. Yes, Likit has also tell it correctly. Can you use new stack? No, no, no. Can't use new stack here, Parag. Pop all them one by one inside a bottom. Totally. Ekta has also said the same thing. Can you show the question again? Question is similar, Deepak. We have this stack, and we want, and in this stack, these are four elements which are inserted, 4, 3, 2, 1, and we want to reverse them. So after reversing, they will look like this. One would be at the bottom place, two would be your second bottom, third, and fourth. They should be looking like this. Like four chairs are there. This is bottom chair. उसके ऊपर ये, उसके ऊपर ये. अब तुमने chairs को उल्टा कर दिया. So जो सबसे टॉप पे थी वो बॉटम पे आ गई. Second top, second bottom बन गई. Third top, third bottom बन गई. Understood, Deepak? That was the question. And I think Likit, Hariharan, Ekta has already given the right answer. And I already showed you how this will happen. So we can use the insert at bottom method to achieve the reverse also. So you guys want to try it? I think the code is already written here. You can see this thing. This is inserted element, which we have already done it. You see, guys, they are doing return at the end. Somebody was asking like return is not there, so they were doing the return at the end. So you guys want to try it? Same code, remove tab to tab code, or remove tab code, temp code. No, temp will also be there. Suraj, temp will also be there, right? Ignore. Okay. Okay. So where is that? Yeah. Easy problem. Yeah. If you guys want to see the code, so this is the code. If this dot is empty is not there, so just simply do the pop, do the reverse, same call the reverse again and again, do the popping, and at the end call the insert element at bottom. See, in previous code they were showing properly written and everything. See, in the reverse call they are not showing properly written, but yeah, at the end return will also be there. Okay. But yeah, that's what I'm saying. JavaScript automatically, when it sees there is no next line, automatically it returns from there. Okay. I'm not sure why police siren is today. They are just patrolling on my road only. Let's see in the next question, guys. That's also a little bit. Now these all questions are related, like very similar. Okay. What is this question? Oh, okay, yeah, this question. Okay, yeah, this question is actually valid parenthesis. Okay, let me first remove my changes which I already did it. Yeah, this is like actually available in lead code also. This question. The next question, valid parenthesis. You guys are able to see my screen, right? Yeah, I have not stopped it. Okay. Okay, so like guys, this is our last question of today's, and then I think we have assignments question for you guys, which we can discuss it, and then you guys can practice it. But let's talk about our last question of class, which is not very difficult, I would say truly. But yeah, question understanding is important here. So they're saying they will be giving us one string S, which is going to contain these characters only. Just these characters, like square brackets, curly brackets. There would be open curly brackets and closed curly brackets. Okay. Now you have to determine whatever input they are providing, that input is valid or not, and how you have to determine that. And these conditions they have provided. Open brackets must be closed by same type of brackets. So like if you got the open brackets, so you must be getting the closed bracket also. If you got the open bracket in your string, then you should get the closed bracket also. Then only it will be valid string. If not, then it's the invalid string. Okay. Let's see next condition. open brackets must be closed in the correct order. Open brackets must be closed in the correct order. What does it mean? It means if you got one open bracket, after that only closed bracket should come. After that only closed bracket should come. You can see the examples also. You see, this is the open bracket, this is the closed bracket. They are saying this is valid string. You see down also, open bracket, closed bracket, open bracket, closed bracket, open bracket, closed bracket. So open bracket must be closed in the correct order. Wherever the open brackets are coming first, those should be closed in the same order as they are coming. Now you can see that in the last, they have given the open bracket, but there was not the closed bracket for that. And even the correct order is also not there. So they are giving this is the false string. Next condition, every closed bracket has a corresponding open bracket of same type. So same type. It means if there is any closed bracket, so it should have also the open bracket. And वो भी same type का, ये नहीं कि different type का हो. अगर वो curly braces है तो curly braces का open bracket होना चाहिए. Okay? और ये हमारी string के examples हैं. Okay guys? First let me know if you guys have understood the question. Not understood reverse. What is the base case? Base case is same, right? Wherever a stack is empty, that's the base case. There we will stop. Understood, Likit? That is our base condition. For the reverse also. For the reverse also. Oh, done. Okay. For the reverse also. Okay, got it. Do we need to solve using stack? Yes, we are like reading stack, so we'll go with stack only, Nilanjan. Yes. So, did you guys understood the question? First, let me know in the chat. Did you guys understand the question? Everyone? Deepak understood the question this time? Yeah, great. Let's now think about it. Okay, guys. So what we will do here in this question, what we'll do, because they are given very nice conditions to us, and those conditions are like this. See, guys, this is our one valid string. They are saying there would be all open brackets, right? There would be always one open bracket and one closed bracket, open bracket and closed bracket. There will be open bracket and closed bracket. Always would be there. Then that string is going to be valid string, right? So what we are going to do here, guys, we are going to push all of our open brackets, to a stack. All of our open brackets to a stack. So first we will push this one, we'll push this curly braces also, and we'll push this one. So after pushing it out, at the same time, we are going to check for the closing bracket also. So see, first time the code will be like this. First we push the open bracket, this thing. Then the next index we are expecting, it should be closed one, right? Next index which we are expecting, it should be closed one. So we'll check. First we will check, is it the closed parenthesis or not? So see guys, we have to do 2-3 things. First we have to check these, whatever the character right now, at whatever index I am, is it the open or close? First we need to check this thing. So for that, we can create a small method or whatever you want to do. So it will be is opened or is closed. This could be small method, which would be just simply checking that this is the open one or closed one. If it is the open, we will insert it into stack. Or if it is the closed one, if it is open, the character is open, we will push into stack. We'll push into stack, right? Or else, if it is not, else if it is closed. So what we'll do, we'll pop it from there. We'll pop it this element. We will, because see, हमें क्या करना है? हमें बराबर के एलिमेंट, हमें ओपन एंड क्लोज सर्च करना है, राइट? As we are moving into this direction, we just simply need to search open and close, open and close, open and close. We just need to compare this open and close. So definitely at the second index, whatever close element is coming, we need to compare it with the which we have recently pushed. Which we have recently pushed. We can definitely do with the temp variable also. We can definitely do with the this with the temp variable also. But there would be in the temp variable, I believe, within the temp variable, the manipulation of temp could be a little bit difficult. But yes, we can definitely try with the temp variable also. But see here, what we'll do, we'll do the stack dot pop, and we'll take this element, and then we will compare it. We will compare it, and if both looks good, we'll say yeah, this is true condition. Just move further, and wherever they do not look good, if the which we have inserted and the next element, if they are like this, we'll return false from here. We'll return false from there. And at the end, our stack should be empty. Our stack should be empty, is empty. Because if our stack is not empty, if our stack is not empty, it means there could be some scenario like this. This could be the scenario, guys. If our stack is not empty, there could be scenario like this, right? There could be scenario like this. Because if we are getting the false one, we have already covered the scenario. For the false one, if we got the extra false, we are already covered the scenario here after the stack.pop. Correct? We have already covered the scenario, that one. But for the open one, if we got the open one, so that we will check with the slack dot is empty. If our slack is not empty, then it means there is some unbalanced characters in the string. Understood, guys? Why I'm saying the slack dot is empty at the last? For this scenario only. If there is any open one which got remained in the string, it means this is not the valid string. This is invalid string. This is invalid string. But it will not come into else if part, because till here everything looks good. This looks good, this looks good, this looks good, this looks good. But this got problem. For this, it will not come into this else if part. So that's why I am checking at the end. If stack dot is empty is true, then only return true. Otherwise, return the false. Otherwise, return false. Let me see in the chat where you guys face the problem. So Likit is saying curly bracket. Yes, this is false. Yes, that is false. That we can check if string dot length mod 2 is not equal to 0, return false. Yes, that's also true. We can do like if there is a odd number of length in a string, so that will be definitely false. So guys, this could be done, this problem could be done in many ways, but I want you to solve this problem with stack. Okay, yeah, with the object also. So I want you guys to solve this problem by stack. First, let me know where you guys faced problem. Anywhere you guys face problem while understanding this logic. We are going to push all of our opening character in stack. For closing, we will take that from the stack and then we will both compare it. If both looks good, it means string is valid. If not, we have some problem here. It means we have some problem here, right? And then at the end, we are checking one more thing. Our stack should be empty. If our stack is not empty, then we are going to see that there are some extra opening elements which has been provided to us. Okay, guys? Everyone understood? What about Nilanjan, Deepak, Sarath, Suraj, Ekta, Hariharan? What about you guys? Where you guys see the problem? Joseph, if I'm just forgetting anyone's name, please let me know. So just practice this problem in the valid parenthesis. I will give you this problem. Okay. That's the problem, Rath. So let me see if I've already kept this logic anywhere. Yeah, and that logic is already actually is already available in the stack branch also. If you first try it in your way, and if you got stuck anywhere, that logic is already available in stack 2 branch. Okay. Let's see what changes I'm pushing right now. Okay, that's fine. Stack changes. Big push. Today, guys, these were just the like very. I would not say that these questions are little bit difficult or anything. This was very easy questions. How to join LinkedIn group? So you just need to raise a request there, right? Let me share the LinkedIn group name, and I would say that, and I would say that, and I would say that please ask queries there only. If you guys have any queries, anything there, and I want you guys to use that as a platform. So let me pass the group name again. Yeah. This is the place. Okay. This is the URL I provided you. So now I will share. So first try to do the assignment question. So let's see. Assignment question, 1 minute. I want you guys to think about the assignment question. Yes. The reversing stack code is also there, Joseph, in the GitHub repo. You can share your doubt, you can share your suggestions, you can share your content. I would also share some Slack. I'm saying I'm also sharing some. I will also share some stack problems there. So first you guys try to practice these assignment question where they are saying you have to sort the element of Slack recursively, and you have to use the same methods: pop, push, and peek. You have to sort this time. You should not create a new array but modify the existing array. Just ignore this line. You should not create a new array. But yeah, you have to think in a similar way. As you think about the reverse and inserted element list at the end, you have to think about this way. Then only you can think about some solution. Same goes for here also. For minimum maximum, I think this would be a little bit tricky to think. But yeah, I would like what you can do. You can take two variables, max and minimum here, and you can keep the both places top value in the both variables, max and min. And then you can start iterating and start popping element and then comparing it out. Like if element is see if you in maximum minimum, let's think about it. Maximum and minimum is not that much tough. You guys, I believe you guys can think about it. You need to first decide maximum and minimum, just randomly any value. Then pop element from here, pop element from the stack, and then compare it. Is it maximum or minimum, something like that? Just think about it. Same goes for sort also, sorting also. Okay. So let's do these questions, and I will share one interesting problem in that group also, which is greatest to write. Great. See, I will explain you one problem tomorrow, and with that one problem, you can solve 4 problems because that follows one pattern. And with that pattern, you can solve 4 problems. So yes, tomorrow class, like next class is going to be interesting, full on coding only. Okay. Okay, guys. So that's all from today. I hope you enjoyed. And this topic was not that much heavy. And so it was very light topic today. And now I will tell you the. Will you tomorrow explain assignment problem? I already explained it, right? I already explained the assignment problems, Joseph. In my next class, I will tell the solution. But before that, I want you guys to try it. Understood, Joseph? Did you not understood the problem, Joseph? I could explain it again. There is one stack. Oh, you mean a solution? Yeah, that will be happen in next class. But before that, I want you guys to practice it. I don't want to share it. It would be great if you guys can do the solution, right? Okay. So yeah, please. So whatever we did today, just practice. It's not tough. So you can just simply practice, and then in lead code, start solving the stack problem. I'm telling you, stack would be lot of places. Oh, really? Ah, it could be office work. Is it? Is it looking like to everyone? A little bit tired. Actually, weather is also changing. Sometimes it's raining, and I'm not turning on my fan. So yeah, I think weather is little bit cozy. So that could be the effect in the body also. After Joseph said yes. Yeah, in Delhi actually it's happening in here also, in UP also. It's raining too much. Okay, guys, so that's all from today. Let's practice it. Yeah. Yeah, so thanks everyone. Have a good night. You guys have tomorrow, Tuesday. So I want you guys to practice this nicely. And I will share some of the problems. I will share the next greatest problem there. Or I will see if any one of similar problem which we have done in the recursion. Yeah. Okay, guys. Have a good night. Bye bye.